The following is a presentation from the Mind, Brain, and Education Science Guide by Tracy Tokuhama Espinosa, and this is from Chapter 6, actually Chapter 7, in which we are looking at interventions or using interventions to help those in certain subject areas. This presentation concentrates on math learning and some of the research that's been done to help with math intervention. We look at numeracy skills. A couple scientists, Stanislas Donherney and Daniel Ansari, and they both did some important research regarding conceptual understanding of numbers, as well as how do we learn numbers, how are they learned. And so when we take a look at a lot of these types of issues that children have with their math studies, we are learning that when we look at the number 3, the Roman number 3, the word representation, and then actually seeing 3 of an item, these all have different areas of the brain that are being used. And we also find from their studies that whatever is used for calculations in math are a lot of the same shared areas that you would see for language. So when we look at someone who's having language problems, we also may see that they're also having math problems as well. So why do students do poorly in math? Well, some of the information that we see is that there are different subcomponents. So these subcomponents are actually are the areas that may be part of their struggle. So there's a lot of different areas that a student could struggle, and it's up to us as educators to determine and analyze what are they exactly having problems with, what sub-skills. So when we look, we have several. To start with, some of the major ones, are they having problems with declarative knowledge? This is basically 3 times 3 is 9, or 5 squared is 25. It's factual information. Procedural knowledge. How do we find the greatest common factor? How do we divide using the long division method? What is the conceptual knowledge that they have? Are they struggling there using reciprocals? For example, knowing why you use a reciprocal when you're actually multiplying fractions or dividing. Estimation skills. So about how many are there? Is it greater or less? And then graphically depicting and modeling math relationships. Can we visualize it? Further research shows that in math there's actually triple coding. I kind of correlate this to music when you have to look at a note, think of the fingering, and then actually understand what it sounds like. So this is triple coding in math, which is the Arabic code string of digits. What do those mean to the student? We look then, how is it analogically represented? What's the quantity when you look at a mental number line? And then finally, what's the verbal code? What's the language? A lot of times, you see a check written in the word form or the language form. So do we understand that? Some of the additional math skills that we need to make sure that they are not struggling in would be their spatial skills, and this is more in the cognitive area, not just related to math, but how do they do it visualizing or drawing or even seeing it in a picture in their mind. Higher order thinking. So how well can they choose to pay attention? What do they pay attention to? How do they relate those new skills they're learning to the old? They're building upon old skills. Do they have those old skills to begin with? And then finally, we have to look at their sensory pathways. Can they see? Can they hear? Can they write? Can they speak? So these are areas that, if those are areas they are struggling with or have a disability with, they're also going to cause problems with math processing. So what are some of the approaches that we can take in math